When you've been working as a professional software engineer for over a decade, you are pretty confident you know your stuff. And when you set out to learn a new programming language, you don't really expect much to change. But oh boy, was I wrong. When I set out to learn Go, it entirely changed the way I think about error and exception handling. And I hate to say it, it made me a better dev in any language. So grab a drink and let's start coding to see what the fuss is all about. In order to really appreciate what Go does so different when it comes to error and exception handling, let's take a look at a very basic TypeScript example to see why error handling can be fairly tricky depending on what you want to achieve. To keep things simple, let's assume this very basic scenario that you have some sort of user input and that user input comes in as a string and you want to ensure that you cast it to a number for some downstream operations. So in this TypeScript example, I will create this function called main. And this main function will take in some user input as a string, and then it will do some stuff here. And then we simply call main so that it gets executed, and we give it the value 5, which in this case would be the user input. Now inside this main function, we want to work with the user input as if it were a number. So a very naive way of doing this would simply be using number, parse int, user input. Alternatively, it would also be something like plus user input. This essentially achieves the same effect. In order to see what happens here, let's create two console log statements, one for the user input and another for the number that we parsed. We also add the type of the variable so that we get a better understanding of if we actually have the correct type that we are working with. Now, if we open up the terminal and we run the TS file, we see that our user input is 5 and a string, and the number that we have is actually also highlighted differently, and it is of type number. Now in the happy case, that's perfectly sufficient, but what happens if we don't have a happy case? For example, the query parameter that we get is corrupt, or the user who uses the CLI tool that you might be building enters a string instead of a number. Well, then things start to get a little complicated. Let's, for example, say instead of a 5, the user missed the key and instead wrote an R. Now, if we go back to the terminal and run the entire thing again, we get the number is none, which in JavaScript stands for not a number, which ironically is still of type number. So just type checking there won't really get you far. Now, depending on what you actually do with this output, it may or may not be a problem. If you save it to a database, for example, and your database expects an integer of some sort, you might run into some fatal exceptions that can be tough to handle and identify where the source of the problem is. So instead of trusting in this naive approach, let's instead build a better parse int function. That is, we have more control over what happens in the edge cases when we get some sort of input that isn't truly a number. In order to do this, let's create a function called better parse int. We have an input of type string, and for now we output a number. And let's just use the naive approach that also parse int does by returning the plus input. If we now use this and wrap our user input in that function, we see that once we open up the terminal, let's clear this out and run it again, we still get the same behavior. So we haven't really done much. The question now is, how do we want to modify our better parse int function? And how we want to modify it really depends on how your downstream code uses the result. So if you're fine with always just checking for is none, then of course, then that's a perfectly valid approach. However, I personally prefer not to have to check that every time. Instead, I would like to do the check once and then be able to trust in the value that I have. Also with none, the problem is that our TypeScript compiler isn't really of much help because none is still of type number, and when we try to use it for some sort of operation, we don't get any errors or any warnings that there might be an issue. A simple way to make the compiler help us is by, instead of just returning a number, we can return a number or null. And we can use the is none check in this single place of the input. And if the input is parsed to a number is none, so not a number, we return null, otherwise we return the parsed input. Now, if we run this again, we can see that we get a null response and it is of type object now. The neat thing about this is if we were to use this number in any sort of, for example, arithmetic operation. So for example, let's say const sum is number plus 10. Then our compiler would actually help us. It would say, hey, potentially there's an issue here because number is potentially null. In order to get around this, we can check if the number is null in advance, and if it is, return early. So we simply do a number is null check, we print something to the console, and then return. Now, if we run this again, we will see that we get the invalid input response and we return early out of main, so no harm is done. So what we have gained by this refactoring is that instead of checking for is none, which is also of type number, now our compiler helps us by saying, hey, you can't actually be sure that at this point this is a number. Instead, you would have to check manually, and then you have an explicit control flow over what to do in each of those scenarios. Depending on your use case, that might or might not be a preferable solution. Of course, since we're talking about error and exception handling, there is an entirely different approach to this altogether, and that would be throwing an exception. So let's get back to our code. And instead of returning number or null, we always return a number. But what we do is we still do the is none check, and if the number is none, we throw an exception instead. In JavaScript, a throw statement acts very similar to a return statement in the sense that you exit out of the function scope. So it's, in a sense, an early return. So we can throw in the scenario if it's a none input, and otherwise we simply return the parsed input. If we run this again in the terminal, we get the expected result, which is that our program throws an uncaught exception. Now, an uncaught exception is usually not a good user experience no matter where you're at. If you're in a server environment, your entire server might crash. If you're building some sort of CLI tool or in a front-end context, then you get a pretty unfiltered error response to your user, which might not be very helpful depending on who your user is. So instead, you would probably want to catch that exception and then act on it. So in our case here, the exception is thrown within better parse int. So in this case, let's just wrap this in a try catch, which allows us to perform some sort of operation when we get an error. In this case, we can just set up a custom error message, for example, invalid input. Now the issue that TypeScript is telling us about is that number down here can't be used because we're defining it within this try catch scope and number is only valid within it. So instead what we can do is we can define it up here as a let instead of a const and define this as a number. And then instead of assigning it to a const here, we just assign it to number. And that will ensure that the number is valid even outside of this try catch block. In order to test if it's working as expected, let's open our console, clear everything, and run error tests again. And we see we get the invalid input message. Now, in this small example, there's not much to worry about, right? We have one function that throws, we have one function that uses the function, and we have a surrounding try-catch block. Simple. But what happens in a very large application where you have a ton of functions, some of them might throw, some of them might not? You have no indication that this is a potentially throwing function, right? I don't necessarily need my try-catch here. And the compiler isn't really informing me about that this might cause some unexpected issues. So one thing to help you with that, you might want to rename your function differently. So you would say better parse int or throw, which is one of the classic ways of naming your functions. But again, there is a lot of complexity that you potentially need to worry about, especially if you add abstraction on abstraction. Because technically now this method or function is being used by another function. So main is now potentially throwing. So now I need to think about, do I want to wrap it in try catch here? Or do I just want to sort of pass the error on through the stack trace by saying main or throw, which already feels very strange. Now we finally get to the part we've all been waiting for, which is how Go does this very, very different. So to start out, let's import FMT, which is part of the Go standard library and just allows us to easily write things to the console. Let's also declare our main function, which Go just automatically executes. Inside this main function, let's assign a new variable called user input, and immediately instantiate this as a string with the contents 5. As it stands, we get a few errors, which is because we don't use the FMT package and we don't do anything with our user input variable, so they're currently unused, and Go really doesn't approve of that. So let's quickly make use of them by writing fmt print line and then use the user input, which should get rid of all of our issues. Now we are faced with the same challenge as before. We have a user input of type string and we want to ensure that we're able to work with it as a number. So in order to do that, the Go standard library provides this package called strconv, which essentially just stands for string conversion. Now let's go down here and create a new variable. Let's just call this num, and we immediately assign it using string conversion and a to I, and then the user input. We immediately get 2 errors. One is, of course, again, that we don't use our num variable. So let's do that straight away with the number is num. But we also get this squiggly line under a to I. And if we hover over that, we see that we have an assignment mismatch, that there are actually 2 return values. So hang on, what is going on here? We see that our conversion function, a to I, always has 2 returns. One is an integer and the other is an error, which means that since in Go primitives can't be null or the equivalent, which is nil, this will always get some sort of number as a response. And in this case, num will be 0, as we will see in a second. But we also get an error back, no matter what happens. And the interesting thing is error is an interface type, which just means that it can also be nil. And GitHub Copilot immediately says here, suggests this check: if error is unequal to nil, then we can print this error and return. Now this is interesting because what it really teaches us about is about the distinction between an exception and an error. An error is really just some sort of object if you're coming sort of from the JavaScript lingo. And what you do with that error is up to you. But what we usually do with an error is we raise an exception, something which goes up the stack trace in your program and until it is being caught, just propagates upwards. In Go, this is very different. In Go, you don't raise or throw an exception. Instead, what you do is you return the error object and you let the caller decide how it should handle that edge case rather than deciding that for it. So enough talking, let's just open up the terminal and run this code to ensure that it actually does what we expect it to do. Of course, if the user input is 5, we don't get an error and everything passes in as expected. But let's change that to an A, clear out of that, and run it again. And we see we get into this error log over here, a to I passing a invalid syntax. Now the fun thing is, as a side note, num is still defined as an integer, and we can actually print it to see what the value is. So if we add the num to the print line statement and run it again, we see the number is 0, which is the default value that any integer in Go is instantiated with. What I found so fascinating about this concept is it's not language specific. It's not something that is limited purely to Go, because, for example, in JavaScript, you also have error objects that you can simply return from a function. You can also return tuples in that sense of just having arrays of fixed length 2, for example. So this is a pattern that we can actually apply. The reason why it's so predominant in the Go ecosystem is for the very simple reason that there is no throw or raise in those simple terms. They do have a panic command, but it is very, very seldomly used and only on very special occasions. And if it is used, it is made very explicit on how to handle that. So now let us take what we've learned and apply it to TypeScript to see how our function might look very different. Going back to our errors.ts file, let's create a generic type called result. And this result takes in a template type T, and it always responds or results in an array of length 2. And the first item of that array is the result of the operation, and the second one is an error. Now we already get Copilot to suggest an implementation here, which we will use. So in this first scenario, the first item of the array is the result that we expect, while the second one is null, which is representing our error. Or in the alternative scenario, we have the first value just being null and the second one being error. This is a little different to how Go handles things, but null and nil between JavaScript and Go are just handled a little differently. And I feel like this is a more natural thing to do in JavaScript. So now we can adjust our better parse int or throw function, first of all, by removing the or throw and typing the result as a result of number. So instead of throwing in here, what we will do is we will also have a return statement, and the first value will be null, and the second value will be the new error we create. And note, this is what we were talking about earlier. Creating a new error doesn't raise an exception, it just creates an object. Raising the exception is what happens when you throw the error. So now we have an early return statement here in case that our input is not a number. And down here we are back in the happy case where we can simply trust that this will result in a number and return null as the error case. Further down in our main function, we can now use destructuring. So instead of assigning number here, we can simply say const, number as our first item and error as our second item. What we can do now is instead of having to check for number is null, we can explicitly check the error case and check if this is unequal to null. And if it is, we get the error here and log it and just do an early return. And in this case, we know that number is a number simply because of the union type. We are sure that we are in this scenario where the error is null. Therefore, we know number is actually of type number. So what we have gained over this scenario where we just return either a number or null in the better parse in scenario is that we're able to provide a reason as to why this result is actually null. In this case, of course, just parsing input straight to a number, there's really only one error case. But you can imagine that there are scenarios which are significantly more complex, and the caller can't be sure why the operation has failed. And in order to provide a more detailed response to the user of your application or to your logs for you yourself to debug, we can now use the error object to contain that message. This, of course, just doesn't have to be the default error object, which in itself is just an object and an interface, but you can define any type of error that you want, preferably extending the default error, and just use that in turn. And of course, to make sure that it actually does the thing that we said it would, let's clear out of this and run the deno command again and get the invalid input error, invalid input, but we see it isn't throwing. And the reason why we still get the entire stack trace is because in the console error down here, we actually log the entire error. And if we instead just use the message property, and we clear this out again and run it again, we get invalid input twice because it's part of the string here and it's part of the error message that we define up here. Now, using what is effectively a tuple response, so an array with a fixed size of 2, where the first item is the result of our operation and the second item being potentially the error, is just one flavor of implementing this. You can also, for example, think of a scenario where you would have a return object instead, where you might have a status code, an error message, and the result of the operation as a property on that object. But what you really use is up to you and the convention that you want to use. What I want you to take away from this is that there is more than one way to deal with errors. Sure, we can raise an exception, but maybe we can also return the error. And with that, in that scenario, make it sort of explicitly the caller's responsibility to deal with that error. That way you move away from a world where any function could potentially throw, and in a very opaque sort of code base, you might have try catches around things just because you don't know whether something in there might throw or not, into a world where the caller is always aware that there might be an error resulting from this operation, and the caller is responsible for dealing with it or passing it on. So what do you think after all this? Do you still think throwing an exception is the best way to go? Or do you think there is some merit to also using this pattern more prominently in the JavaScript TypeScript ecosystem? Leave your thoughts in the comment below, I'm super intrigued to read them. Also, if you enjoyed this video and want to see more in the future, please leave a like and consider subscribing to the channel. This insight was the result of me playing around with a programming language I hadn't touched ever. And if you are considering trying out a new programming language, then I highly recommend this video by Kyle from Web Dev Simplified, who goes to the reasons why you might want to try a new language and when the best time is to do so. The link to the video is in the description below. Go check it out, have fun, and see you around next time.